So number three is a weird one. Why is that? I think someone just very quietly mumbled at me that there's a missing X. Did that come from over there somewhere? Is that one of you guys? I'll take that as a yes also. Okay. That was like next level. Thank you. Yes, the top equation is missing its X. So basically, we're going to take that equation, the top one, and we're just going to kind of package it over off to the side, and it's going to wait. So the negative 6y plus 8z is just waiting for a mate, another equation just like him that doesn't have an X. And so we have two remaining equations that we're going to use to get rid of the X. And it just so happens this is sort of fluffer puffery in the sense that if you take these two bottom equations, they're actually already sort of kindly built for the X's to auto eliminate. So I can simply do row 2 plus row 3. I don't have to make any modifications at all. Usually, I think like 7 or 8 times out of 10, you're going to have to multiply and make something like turn a 3 and a 4 into a pair of 12s or something like that. But in this case, the X's are like, here we are, come grab this. So what do we get if we add row 1 or row 2 to row 3? How many X's? None, right? How many Y's? 9 Y's, good. How many Z's? Negative 8 Z's. And then what's the constant going to be? Yeah. So we may want to do another one after this just because this one is sort of next level fluffer puffer. We saw one of these in our notes. I think it was the first one we did where it just kind of fell apart right in front of us. Not in a bad way, like it just dissolved and was like, oh, this is easy. Because now we have a 2 by 2 system to solve. And what's so nice about this one? The Z's are already ready to go. And so right now I can just add the top equation and the bottom equation together. Understand, objective one usually takes longer than that. But in this case, one of the 2 by 2, one of the two variable equations was already given to us. The other one just fell right into our laps. So we're just ready to go. And so if we add these two equations together, the z's will cancel. How many y's do we get? We get 3. Just add straight down that column there with the y's. And then the z's eliminate, of course. And what's our constant going to be? Good. And if 3y equals 6, divide by 3. And just like that, we already know. Again, it usually takes way longer than that to get a third of the way home, but we're there. So we now know our final answer is something to something. And we want to make sure we put the 2 in the second spot because it's an ordered triple, x, y, z. Which variable do we have to find next? This is not a touchy-feely sort of kind of question. What do you have to do now? You have to find z. And the reason is because you have to go someplace to an equation that only has 2 variables. We don't have enough ammunition yet to do 3. So I'm going to go pick an equation that has 2 variables, and you could select either of these two. They're both perfectly good candidates. Which one do we like better? Top's fine. Yeah, the top has a little bit smaller numbers. It does have a negative on the right, but at the end of the day, like we're not in 5th grade, right? A negative's not going to keep us up at night. So if I take that top equation, the one I'm circling, and I rewrite it, but I change the y into 2, it'll now say negative 6 times 2, because that's no longer a y, because we know what y is, plus 8z equals negative 20. And again, barring rinky-dink, goofy mistakes, we're almost there. What's negative 6 times 2? Negative 12. I don't know why everyone's whispering at me today, but I'll stop asking you questions. Good. So after this, we're going to add 12 to both sides. And we're going to get 8z equals negative 20 plus 12 is negative 8. And then we divide by 8 and we get z equals negative 1. So we have completed 2/3 of the puzzle. And we're going to put the negative 1 now where z goes in the third spot of the ordered triple. And now we have enough strength to go and finish the job, storm the castle. It's time to go rescue X. If I know Y and I know Z, I can go into either of these two equations in the green box. But I can't go anywhere other than that because those are the only two equations that present an opportunity to solve for X. So if I consider that there's, again, 2 of them, which one do we like better, top or bottom? Top's fine. And you're going to get the same outcome either way. And I am going to erase a little bit. You would not do this because you know that I would want to see your work, but I'm just going to clear a little bit of space up here. So I'm going to take the top equation, that's this one, and I'm going to write it again. But when I get to the variables that I know, I'm not going to put variables, I'm going to put numbers. So it's going to say negative 5x plus 4 times 2, because that's y, minus 3 times negative 1, because that's z, equals 6. And it's really just, I mean, that's all this has ever been. It's just, bless you, it's just a lot of basic skills going on here. So, having said that, let's clean it up a little bit. We get negative 5x plus 8 plus 3 equals 6. And then, of course, your algebra teacher, whoever that guy was, would have taught you to combine like terms. So we have negative 5x plus 11. You always combine your like terms when they're on the same side of the equal sign. You don't want to start the solving process until you've cleaned it up entirely. And then if I subtract 11 from both sides, I get negative 5x equals 6 minus 11, negative 5. Divide by negative 5, I get x is 1, and I am done. So I think that is probably, I would think that once you're able to understand this for what it is, if when you take a quiz on this later this week, that would be what you would desire and say that's the easiest question on the quiz. That one was really gift wrapped for us in a lot of different ways. Would you like to do another one? I mean, I doesn't matter to me. This is all, anything stand out? Sure. Like number one, doesn't look very fluffer puffery to me. And I feel like of all of the rows, columns, I would not pick the Z's. I think Z's would be a rough choice because the smallest number that you can turn 4, 6, and 5 into is 60. So generally, we would stay away probably from that. I mean, it's not like you couldn't do it, but why pick that path, right? So having said that, would you like to eliminate the X's or the Y's? Yeah. Y's are fine. Good. So let's get rid of the Y's. So what we do have to do now is prep it. We have to prep the system. And 5, 2, and 5 can and should all be made into tens. So I'm going to now attack the system row by row. I'm going to multiply this row by 2, the middle row by 5, and the bottom row by 2. You do whatever you want because each row is its own equation. So we can multiply each one independently by whatever we want. So this is more what you can expect is a system like this where you've got to like pre-treat it before you get in there and start eliminating stuff. So the top row is going to be 4x plus 10y minus 8z equals 2 times 8, 16. Middle row is going to be negative 20x minus 10y minus 30z equals 10. And then bottom row is going to be 12 of those plus 10 of those plus 10 of those equals 2. So the system's prepped. And now we're going to do what we came to do. We're going to cash in that work now, and we're going to eliminate the Y's. What was nice about all of the situations or scenarios that we had there is that we didn't have to tinker with any signs. Had we decided to kill the X's, and by we, I mean you guys, we already had a positive, negative, positive. You need that dynamic where one is offset from the others. And we got it in the Y column too. We have positive, negative, positive. So having said that, what's our first row operation going to be? What's our first row operation going to be? R what plus R what? Row 1 plus row 2 is a great answer. So let's all agree that we're going to do R1 plus R2. And remember, do not put an equal sign after that. Just put a little arrow or something else to indicate like incoming here. Because what we're going to do now is we're going to create the first of the 2x2 equations. All right. So incoming equation with no y's. Perfect. How many x's are we going to get? Negative 16 x's. The y's, I'm not going to ask. They're going to cancel. How many z's are we going to get? Negative 38. And then the constant term is going to be 26. Good. All right. What's the next row operation that we have to do? Don't have a choice here.
Row 2 and row 3.
That's it, Riley. Row 2 plus row 3 is the only other correct answer. And we say that because of what I'm circling in red. We've already got a negative 10 and a positive 10 built. We made that. We did it for a reason, because now when we cash it in, when we add row 2 to row 3, those y's are going to disappear. So we're going to do R2 plus R3. I would like to remind you that if you do not include this stuff over here that I just circled in green, I will not grade your test. I'm not going to spend my time trying to read your mind and predict, like tap into your mindset and try to, figure out what you did. So that communication piece is essential. So you've communicated to the world, you're going to add the second row and the third row, and here we go again. How many x's do we get? And I'll bracket them for you just so you can focus. We're doing the 2 rows with the green bracket. All right. So we don't even look at the top row now. We're just doing row 2, row 3. And I heard someone whisper -8. That's perfect. So we have -8 x's. And then the y's, of course, are going to cancel. The z's are going to be -30 plus 10, which is -20. And then the constant is going to be 10 plus 2, 12. All right. So this had some potential to be a little bit intimidating. And you do have options. I get this question usually about the time people start to get comfortable with the process. The question comes out and people say, can I divide instead of multiplying? And the answer is, of course you can. So like some people might take the top row and divide it to make the numbers smaller, right? That's in play. But just to not confuse anybody, I'm going to do this sort of by the book. And which variable is more attractive? There's a very, very clear answer here. X's. Like, no way would anyone choose Y's. Because trying to make 38 and 20 into the same number, that's, no way, man. So we're going to multiply the bottom equation, this one down here, by what? Nope. Well, now that is what I need, by -2. And that's critical because I don't want them both to be the same. I want them to be opposites of each other. So I've got to do the sign switch. So I'm going to take the top equation and just copy it over. It's a few seconds of annoying work, but it does pay off in the end just for tidiness, to keep you on the right track and to make my life easier when I go to grade these. Okay. Now the bottom equation that I'm about to write is going to be the tinkered one, the one that we're going to multiply by -2. So my x's are now going to be 16. And that's what I came for. The rest is just collateral. It's whatever I get. I don't really care at this point. My objective has been accomplished. So when I multiply by -2, I get plus 40 of those z's. And then my 12 becomes a -24. So, I mean, in the same way that this purple box up here, we worked to make that. We worked to make this. Every time, every step along the way, you're trying to create a system that will eliminate for you. And that's what we've done. First, the 3x3 to eliminate the y's, and now the 2x2 to eliminate the x's. Bless you. So when I add these two equations together, the x's are gone. The y's are going to be -38 plus 40, which is 2. Or the z's, I don't know if I said y's. Z's are going to be 2z. And then 26 plus -24 is 2. And just like that, you get z equals 1. So the puzzle is a third of the way complete. I'd say this sometimes, I feel like we're a third of the way to the answer, but we've done like more than 50% of the work. I don't know why it always feels that way to me. Like Just because we only have 1/3 of the answer doesn't mean we're only 1/3 of the way. I feel like the rest goes quicker. So I'm going to write my answer. That's what I always do. So I'm going to go blank, blank, 1. Make sure you put the Z in the correct spot, ordered triple. Who do we have to find next? X. Because I need an equation that has Z and one other variable, and the only ones up on the board are the X and Z ones. And so there are 3 possible equations that you could use. There's the 2 original in the green box, and then there's the 1 modified in the smaller green box. Freedom of choice. Which one do you want? You want the modified one? Oh, sure. It's fine. And again, everything's going to come out in the wash. It just doesn't matter. So I'm going to take that. That's not the one I would have picked, but it is important to understand that we can pick whatever one we want. It doesn't matter. So I'm going to take that one in the smaller green box, and I'm going to rewrite it as 16x. So that's this one here is going to be 16x plus, and I don't think I need to show work on this, right? 40 times z is 40 times 1, which is just, well, 40. Right. If you want to multiply those as you go, feel free. Just don't do anything crazy. Don't mess up signs and stuff like that. And then on the right side, we're going to have the equals -24. Be careful, be vigilant, make sure you're copying the correct equation. It's really easy. You look away for 1 second, come back, and your eyeballs can go to the wrong equation. So make sure you stay focused on where you are. So we get 16x equals, what is that, -64? Subtract 40 from both sides, right? And then you get x equals -4. So -4 is going to plug the first spot, and now we're ready to finish the job. I'm going to erase a lot of stuff here. I'm recording this, so whatever. Like if anyone was like, "Whoa, no, I wasn't done," they could pause it or whatever. But at this point, I'm just going to tidy up just to make my point. And my point is that you're going to have a ton of work on your paper at this point in time. It's important that you focus and make good choices. You would be crazy to not pick one of these original 3 equations, right? Could we do it? Sure. Like Parker and I just proved on the last one, you can pick a bigger modified equation, but I don't know why we would. So of the 3 OGs, which one do we like the best? Probably the top. It feels friendly. It just looks nice. And so I'm going to rewrite it. But every time I get to a letter that I know, I'm going to replace the letter with what I know it to be. So for example, in the first part of it where it says 2x, I know x is -4. That's -8. So I can just write -8. The thing I don't know is y. And so when I get to the term that says y, I have to leave it as a variable. So it's +5 times the thing I don't know, right? And then the z, I also know. So it's going to be -4 times 1, which is just -4, equals 8. And again, I work hard in Algebra 1 on this. There's some people that still sneak through, fall through. Do not add 8 to both sides. Do not add 4 to both sides. Combine your like terms that are on the same side. And so the 5y is just going to sit here and wait while we put the -8 and the -4 together to make -12. It's like Algebra 101. Clean before you solve. And then we're home free. Add 12 to both sides. You get 5y equals 8 plus 12, 20. Divide by 5. Y is 4. And we are done. That was a really good example that we got to go over there. That's pretty much just covers it all. Prep the 3x3, do 2-row operations. Prep the 2x2, eliminate, and then scaffold your way back up. That's what the normal problem should feel like. The only way that these can get worse, and I'll let you work after this, is after you do your where you prep your triple system and you get down to the 2x2. I just wanted to talk to you about this. What would you do? And I'm just making this up. Just want to say this so that if it happens, you don't panic. If you could ask me right now what 15 and 19 could both go into, and I would tell you, I'm not sure. Ask me what can 34 and 23 both turn into, and I'd say, I don't know. What's the workaround here? When I don't know what they don't divide. Good. So I mentioned this last week. Good. So that's I want to make sure you're aware that when it's not like that last one was kind of nice because we had an 8 and a 16. And everyone knows that you can turn an 8 into a 16. That was pretty easy. But in a case like this, let's say you wanted to eliminate the x's. I don't know what the answer to either of these two math problems is going to be. But I know this. If I multiply this one by negative 15 and this one by positive 19, I don't know what the answer to that yellow question is, and I don't know what the answer to that green question is, but I know they're going to cancel out, right? So remember that trick. If you get out of your comfort zone and you get a 2 by 2 that's a little bit like, ooh, just multiply by each other. Make sure you get your signs to offset, and then your calculator village from there, right? Be real vigilant, deliberate, type in numbers. It'll work out. All right. Any other questions? All right, the rest of the hour is yours to work on this, get it done. That's it. I'll leave the recording alive, paused as always. If someone gets to something and I'm like, whoa, that's crazy, then I'll put it back in the recording. Cool. Number four, I would venture to say that even if you're not on number four, you should stop what you're doing and give me just a quick moment of your time. Number four inevitably is going to make you want to ask questions. So the first thing that we notice about number four is that the X's are ready to cancel, right? And so what happens is you get what I call if we were playing Halo, I call this like a double kill. And so when I add row one to row two, thank you. I'm going to turn it on right now. So when I add row one to row two, what I set out to do, I would assume what you all noticed when you get to problem four, what you would notice is that the X's are ready. This is a next level fluffer puffer, right? So when I add row one to row two, I wanted the X's to eliminate, which they did. When I add the Y's together, I get -2 of those. And then this is where the confusion sets in. I add the Z's together and I'm like, what the what? They also eliminate, right? The Z's in row one and row two. And I'm left with just equals 10 plus -14 is -4. It's really easy at that point to say, I'm going to panic here and not know what to do. Let's take a look at what happens when we do the other row operation that was gifted to us. The other way, we'll come back to that, don't worry. The other row operation that's given to us is row 2 plus row 3, because the x's again are auto built, -5 and 5. So when I do row 2 plus row 3, again, what I set out to do here was eliminate the x's. And yes, they eliminate. But then I get to the Ys and I'm like, again, a double kill? The X's I meant to go poof. The Ys poof came along for the ride. And I'm left with 3z plus -5z is -2z equals -14 plus 24, which is 10. It's at this point that you would want to say, what do I do from here? I completely understand. But I'm here to tell you this is actually now going to replace problem 3 as the easiest problem on this worksheet. Because if I take this top red equation right here, the one I just bubbled in purple, and I solve it, I now know that y is equal to 2. Done. And what's even better is if I take this one that I'm circling in green and I solve it down and I divide both sides by -2, I now know that z is -5. I actually already have 2/3 of my answer. My answer is blank 2 -5, and I'm ready to storm the castle. It is very rare for it to happen that quickly, but the two, like we set out to kill the X's. I want to be clear about this. When this problem was generated by the computer, it generated X's so that they were ready to go right there. Boom. And what we got was a lot of extra bonus stuff that came along for the ride. So at this point, you could now storm the castle, go back to the original 3 equations, and let's just say that I pick the top one, the one that I'm circling in purple up here. If I rewrite that equation now, it's going to say 5x minus 5 times y, which is 10, minus 3 times z, which is plus 15, because -3 times -5 is positive or plus 15. And just like that, we're on the doorstep. Got it? I mean, so that one just, that one just dissolved just into dust. Nothing. So we're left with 5x plus 5 equals 10. 5x equals 10 minus 5. X equals 1. Problem over. Shortest problem in the history of 3x3s. So when you encounter things eliminating that you didn't mean to eliminate, don't panic. It's actually a bonus. It's a good thing, right? Okay, carry on then.